The information provided in this video is for educational and entertainment purposes only. Automotive repair involves inherent risks, including potential property damage and personal injury. This content does not constitute professional mechanical advice, legal guidance, or a substitute for a certified technician's diagnosis. Every vehicle is unique, and repair procedures can vary significantly based on make, model, year, and specific wear and tear. Viewers are strongly encouraged to consult their vehicle's owner's manual and seek the services of a licensed automotive professional before attempting any repairs or making significant maintenance decisions. Conduct your own due diligence regarding the reputation and certification of any repair facility mentioned or described. The car sitting in your driveway right now is a lie. You bought that Toyota, Honda, or Mazda because the internet, your parents, and every historical trend suggested it was an invincible fortress of engineering. You believed that as long as you changed the oil every 5,000 miles, that engine would hum until the year 2040. But here is the reality that most US car owners are waking up to in 2026. The gap between Japanese engineering and American repair standards has become a multi-billion-dollar graveyard of premature engine failures and brick transmissions. We are seeing a documented rise in Japanese vehicles being retired before 100,000 miles, not because the cars are getting worse, but because the average American repair shop is fundamentally incapable of servicing them to the required tolerances. In the next 10 minutes, I am going to show you why the 18-year-old kid at the corner lube shop might be accidentally sabotaging your car's lifespan by using a single incorrect fluid type, and why your local mechanic's all makes all models approach is a high-stakes gamble with your second most valuable asset. If you think a wrench is just a wrench and oil is just oil, you are the exact person the industry is profiting from. This is the deep dive into the specialized world of Japanese auto repair shops in the USA that will change how you view your vehicle forever. The problem we are solving today is the erosion of reliability. For decades, Japanese manufacturers like Toyota, Lexus, Honda, and Subaru have built their reputation on the philosophy of monozukuri, which translates to the art of making things. This isn't just a marketing slogan. It is a rigid adherence to technical specifications that are often measured in microns. In the United States, however, our repair culture has historically been one of good enough. We use universal parts, we use multi-vehicle fluids, and we use diagnostic tools that only scratch the surface of the car's true internal data. This guide is designed to bridge that gap. By the end of this series, you will possess the specialized knowledge required to vet a shop like a master technician. You will know exactly which certifications actually matter, which proprietary diagnostic softwares are non-negotiable for your specific model, and how to identify the subtle red flags that suggest a shop is cutting corners on your JDM-engineered machine. We are moving beyond the surface-level advice of looking at Yelp reviews. We are going into the chemistry of fluids, the physics of torque-to-yield bolts, and the economics of the Japanese parts supply chain in North America. To understand why a specialized Japanese auto repair shop is a necessity rather than a luxury, we have to look at the historical trends of vehicle complexity. In the early 2000s, a Honda Civic was a relatively simple machine. A talented amateur with a basic set of metric sockets could perform a significant portion of the required maintenance. Fast forward to 2026, and a standard hybrid powertrain in a Toyota RAV4 or a turbocharged Skyactiv engine in a Mazda CX-90 operates on a level of sophistication that rivals aerospace engineering. These vehicles utilize high-pressure direct injection systems, complex thermal management loops, and integrated electric motor generators that require specific insulating resins and cooling properties in their fluids. Consider a case study involving the Honda CVT, or continuously variable transmission. In many general repair shops across the US, a technician might see a CVT and reach for a universal CVT fluid. On paper, the bottle says it is compatible with most major brands. However, historical data from transmission specialists shows that these universal fluids often have different frictional coefficients than the genuine Honda HCF2 fluid. The result isn't immediate failure. Instead, it is a microscopic increase in heat and belt slippage. Over 20,000 miles, this leads to a shudder that eventually requires a total transmission replacement costing upwards of $6,000. A specialized Japanese shop knows this. They don't stock universal fluids because they understand that the Japanese engineers tuned the transmission's pressure solenoids to the specific viscosity and chemical makeup of the OEM fluid. This is the level of detail we are talking about. Furthermore, we must address the Toyota tax and the misconception of invincibility. Many American owners treat their Japanese vehicles with the level of neglect they would never show a German car. Because Toyotas have a reputation for never breaking, owners often skip preventative maintenance or take them to the cheapest possible service center. This creates a secondary market of used Japanese cars in the US that are maintenance-deferred nightmares. A specialized shop acts as a guardian against this. They understand the specific failure points that are unique to these brands. For example, a specialist knows that while a Subaru Boxer engine is legendary for its balance, it requires a very specific coolant chemistry to protect the head gaskets from electrolysis. A general shop might use a standard green or orange coolant, which can lead to premature gasket failure 3 years down the line. In this masterclass, we are also going to break down the diagnostic gap. Most general shops use a tool called a snap-on or an auto scanner. These are fantastic, versatile tools. However, they are the equivalent of a general practitioner's stethoscope. A specialized Toyota shop will utilize a system called TechStream. A Honda specialist will use the IHDS, Honda Diagnostic System. These proprietary platforms allow the technician to see hidden data PIDs, things like individual cell voltages in a hybrid battery pack, or the specific step count of an electronic wastegate actuator. When you take your car to a generalist, they might see a check engine light and give you a broad code. When you take it to a Japanese specialist, they can see the exact millisecond a sensor lagged, allowing them to fix the root cause rather than just throwing parts at the symptom. We are also going to explore the labor philosophy. In Japan, the shokunin spirit, the pride of the craftsman, is deeply embedded in the design of the vehicles. The engineers expect the person servicing the car to follow a specific sequence. For example, on many modern Lexus models, there is a specific sequence for bleeding the brake system that involves a laptop-driven command to the ABS actuator. If a shop tries to old school bleed those brakes by having someone pump the pedal, they can actually damage the expensive internal valving of the actuator. This is where potential outcomes become catastrophic realities for the uninformed owner. This series is your roadmap to avoiding those pitfalls. We will cover the geography of repair, identifying why certain regions of the US have better access to Japanese specialists than others. We will look at the supply chain, explaining why made-in-Japan parts are often superior to designed-in-Japan, made-elsewhere components. We will even dive into the specific certifications you should look for on the wall of a lobby, moving past the basic ASE logo to find L1 Advanced Engine Performance and Hybrid/Electric Vehicle Specialist badges. By the time we are finished, you won't just be looking for a mechanic. You will be looking for a technical partner who understands the DNA of your vehicle. You have invested tens of thousands of dollars into a piece of Japanese engineering. Now it is time to invest the time to ensure that engineering isn't undone by a lack of specialized knowledge. Let's begin the deep dive into the infrastructure of the American-Japanese auto repair industry. To understand the current state of the American-Japanese auto repair industry in 2026, we have to look at the hierarchy of the repair landscape. Imagine if you are Mark, a resident of a growing suburb in North Carolina. It is 2026, and Mark is the proud owner of a 2024 Toyota Tundra Hybrid with the iForce Max powertrain. This truck is a masterpiece of complexity, blending a twin-turbo V6 with an integrated electric motor generator. When a warning light appears on Mark's dashboard indicating a hybrid system malfunction, he faces the first major fork in the road of modern vehicle ownership. In the United States, there are 3 tiers of repair infrastructure available to him: the massive franchise dealerships, the generalist big-box repair centers, and the independent Japanese specialists. Mark's decision will dictate the potential outcomes for his vehicle's longevity and his own financial health. If Mark takes his Tundra to a generalist shop, he is entering an environment built for volume, not nuance. These shops often employ technicians who are forced to be jacks of all trades. In a single afternoon, a technician might work on a domestic heavy-duty diesel, a European luxury sedan, and then Mark's high-tech Toyota hybrid. The historical trends suggest that this lack of focus leads to a reliance on universal diagnostic tools. These tools are essentially translators that speak dozens of automotive languages but are fluent in none. When Mark's Tundra is plugged in, a general tool might return a generic fault code like P0A80, which signifies a general hybrid battery pack failure. In a high-stakes scenario, a generalist shop might see this code and immediately recommend a full battery replacement, costing Mark upwards of $7,000. This is what we call the diagnostic trap. Now, consider the alternative. Imagine if Mark chooses a specialized independent Japanese repair shop. In 2026, These shops are the elite special forces of the automotive world. When they see a Tundra hybrid, they aren't reaching for a universal scanner. They are firing up a dedicated Panasonic Toughbook running Toyota TechStream, the proprietary software used by the factory. This specialist doesn't just see the P0A80 code. They can drill down into the live data of the hybrid control module. They can see the internal resistance of every single cell block in the battery. They can monitor the RPM of the dedicated hybrid cooling fan and the temperature of the intake air for the battery pack. Through this deep dive diagnostic, the specialist discovers that the battery isn't failing. Instead, a specific cooling duct has become restricted by debris, causing a localized overheat that triggered the code. The potential outcome? A $250 cleaning and recalibration service instead of a $7,000 replacement. This isn't just a story. This is a case study in the value of specialized knowledge. The infrastructure of these specialized shops is built on 3 pillars: certification, chemistry, and components. Let's start with certification. In the US, the gold standard is ASE, or the National Institute for Automotive Service Excellence. However, for a Japanese specialist in 2026, a basic ASE certification is the bare minimum. You should be looking for technicians who hold the ASE L1 Advanced Engine Performance Specialist or the L3 Hybrid/Electric Vehicle Specialist credentials. These certifications require a level of mathematical and electrical understanding that far exceeds standard mechanical repair. A shop that invests in these certifications is signaling that they understand the shifting landscape of 2026, where cars are essentially high-voltage computers on wheels. The second pillar is chemistry, specifically regarding fluids. This is where the average US car owner unknowingly damages their vehicle. Historical trends in Japanese engineering show a move toward extremely low viscosity oils and highly specific coolant chemistries. For example, many 2026 Toyota and Honda models utilize 0W8 or 0W12 weight motor oils. These oils are almost as thin as water at room temperature. They are designed to reduce internal friction to meet stringent efficiency standards, while still providing protection through advanced additive packages. A generalist shop may not stock these niche weights and might substitute a 0W20, thinking the difference is negligible. However, in a high-precision Japanese engine, that slightly thicker oil can lead to improper timing chain tensioner operation or reduced flow to the turbocharger bearings. Similarly, Japanese manufacturers almost exclusively use POT, phosphate hybrid organic acid technology, coolants. If a shop tops off your Mazda or Subaru with a standard silicate-based coolant found at a big-box retailer, the resulting chemical reaction can create a silicate dropout that clogs the radiator's tiny passages, leading to a slow-motion overheating death for your engine. The third pillar is components or the parts economy. Specialized Japanese shops in the US generally avoid the white box parts found at local auto parts chains. Instead, they tap into the Japanese OEM, original equipment manufacturer, supply chain. They know that while the box might say Toyota, the part inside was actually made by Denso, Aisin, or NGK. A specialist understands that a Denso alternator is engineered with specific copper winding densities that a generic $150 remanufactured unit simply cannot match. In 2026, the communication between parts is so sensitive that an aftermarket oxygen sensor might have a slightly different electrical resistance than the original. This can cause the engine control module to miscalculate the air-fuel ratio, leading to a 5% to 10% drop in fuel economy. Over the course of a year, that drop in efficiency effectively taxes the owner for choosing the cheaper part. We also have to discuss the physical infrastructure of the shop itself. In 2026, the complexity of Japanese Advanced Driver Assistance Systems, ADAS, has reached a tipping point. If Mark's Tundra requires a simple wheel alignment or a windshield replacement, his safety hangs in the balance of sensor calibration. The cameras and radar units that power adaptive cruise control and lane keep assist must be calibrated to within a fraction of a degree. A specialized Japanese shop will have dedicated floor space that is perfectly level, often to within 3 millimeters, and specialized target boards designed for specific Japanese brands. Without this infrastructure, a car might track straight down the road, but its emergency braking system could be looking 2 feet to the left of where it should be. The American-Japanese auto repair industry is currently undergoing a massive transformation. As vehicles become more integrated with software, the line between a mechanic and a software engineer is blurring. The shops that are thriving in 2026 are those that have embraced this reality. investing in high-speed fiber optic connections for cloud-based diagnostics and thermal imaging cameras to find electrical shorts in complex wiring harnesses. They are moving away from the greasy garage stereotype and toward a laboratory environment. But how do you, as a consumer, identify these elite facilities from the outside? How do you distinguish between a shop that just puts a Japanese auto specialist sign in the window and a shop that actually lives the philosophy of specialized repair? There are specific, measurable red flags and green flags that you can spot before you ever hand over your keys. In the next part, we are going to look at the lobby test and the 3 questions you must ask a service writer to determine if they are actually qualified to touch your vehicle. We will also reveal the truth about the dealership alternative and why the most expensive option is rarely the most competent one. If you have ever felt like you were being spoken down to at a repair shop, the next segment will give you the vocabulary to take back control of the conversation. Do you know which specific fluid color is a dead giveaway that a shop is cutting corners? We are about to find out. The specific fluid color that acts as an immediate red flag in 2026 is the presence of neon green or bright orange coolant in a modern Japanese cooling system. If you walk through the service bay of a shop and see a universal drum of green fluid being pumped into a 2024 Honda Civic or a 2025 Toyota Corolla, you are witnessing a slow-motion chemical disaster. For over 2 decades, Japanese manufacturers have moved away from high-silicate green coolants toward phosphate hybrid organic acid technology, or PHOAT. Toyota uses a distinct pink fluid, known as super long-life coolant. Honda, Nissan, and Subaru use a specific shade of blue. These fluids are chemically engineered to protect the specific alloys and plastic composites used in Japanese water pumps and radiator cores. When a generalist shop mixes standard green coolant with Japanese blue or pink, the phosphate additives can drop out of the solution, creating a gel-like sludge that coats the internal passages of the engine. In a high-stakes scenario, this leads to localized hot spots in the cylinder head, which eventually results in a warped head gasket. This is why the visual audit of a shop's inventory is your first line of defense. Imagine if Sarah, a healthcare administrator in Seattle, takes her 2023 Lexus RX 350h in for a routine cooling system service in 2026. Sarah isn't a mechanic, but she has done her due diligence. She performs the lobby test. As she stands at the service counter, she doesn't just look at the free coffee or the comfortable chairs. She looks for the wall of certifications. In a high-end Japanese specialty shop, she should see the ASE Blue Seal of Excellence, but more importantly, she should see factory training certificates from the Toyota T10 program or the Honda PAC program. These certificates indicate that the technicians have been trained by the manufacturers themselves, not just a general vocational school. Sarah then looks through the window into the shop. She is looking for the jugs. If she sees rows of Aizen, Denso, or genuine Toyota/Honda fluid containers, she is in a facility that respects the engineering of her vehicle. If she sees only generic, unlabeled white buckets, she knows the potential outcomes involve premature component failure. This leads us to the 3 critical questions you must ask the service writer before you sign a repair order. Question 1. Do you use factory-level J2534 pass-through diagnostics or a universal scanner? This is the technical gatekeeper. In 2026, many Japanese vehicles require cloud-based authentication to perform even basic tasks like battery registration or electronic parking brake retraction. A universal scanner from a big-box tool company might be able to read a code, but it often cannot perform the bidirectional commands necessary to complete a repair. If the shop mentions TechStream for Toyota, IHDS for Honda, or Consult 3 for Nissan, you have found a specialist. If they say our scanner works on everything, they are admitting they lack the depth required for complex modern systems. Question 2. What is your specific policy on universal fluids? This is a trap question. A knowledgeable service writer at a Japanese specialty shop will immediately tell you that they do not believe in universal fluids. They will explain that a 2026 Mazda Skyactiv transmission requires a very specific frictional coefficient that a multi-vehicle ATF cannot provide. They will tell you that using the wrong fluid can lead to harsh shifting or solenoid failure within 10,000 miles. If the service writer tries to tell you that one fluid fits all, thank them for their time and walk away. Historical trends show that the most expensive repairs on Japanese cars in the US are not caused by parts wearing out, but by the wrong fluids being introduced into the system. Question 3. Can you provide a digital vehicle inspection or DVI that includes photos of the specific failure points? In 2026, transparency is the currency of the elite shop. A professional Japanese specialist will send a link to your phone containing high-resolution photos of your specific vehicle. They won't just say your brakes are low. They will show you a photo of a digital caliper measuring the remaining millimeter thickness of the pad against the factory specification. They will show you the exact location of a fluid leak with the dye trace under ultraviolet light. This level of detail prevents the "trust me" dynamic that has plagued the auto repair industry for decades. We must also dismantle the myth of the dealership versus the independent specialist. Many U.S. car owners believe the dealership is the only place to get real service. However, in 2026, the dealership model is often under immense pressure. Dealership technicians are frequently paid on a flat-rate system, which incentivizes speed over precision. A technician might be encouraged to finish a 4-hour job in 2 hours to maximize their paycheck. This is where torque-to-yield bolts are reused instead of replaced, and where complicated diagnostic steps are skipped in favor of parts can guessing. Conversely, a top-tier independent Japanese specialist often operates on a different philosophy. These shops thrive on long-term relationships and reputation. Because they aren't forced to push high volumes of warranty work, they can afford to spend the extra 30 minutes ensuring that every clip and plastic under tray piece is reinstalled exactly as the Japanese engineers intended. Consider a case study regarding the 2025 Honda Accord Hybrid. In a dealership setting, a technician might see hundreds of these a month and become desensitized to subtle anomalies. An independent specialist, however, treats each vehicle as a technical challenge. When an independent specialist performs an oil change on this hybrid, they aren't just draining the oil. They are checking the high-voltage cable shielding for signs of rodent damage, a common issue in many U.S. suburbs in 2026. They are inspecting the hybrid battery cooling filter, a small part that, if clogged, can lead to a $5,000 battery failure. Many dealerships omit this filter check from their express lube service because it takes an extra 5 minutes. The specialist knows that those 5 minutes are what preserve the car's value. The economics of this are clear. While a specialist might charge a slightly higher labor rate than a generalist, perhaps $180 an hour versus $150, the long-term savings are massive. By using the correct PHOAT coolant, the correct 0W8 oil, and the correct DENSO sensors, the specialist ensures the car reaches its 300,000-mile potential. The generalist, through a series of small, good-enough decisions, often inadvertently caps the car's lifespan at half that. In the U.S. market of 2026, where the average price of a new Japanese SUV has climbed toward $50,000, protecting that investment through specialized care isn't just a hobby, it is a financial necessity. As we move deeper into this masterclass, we have to look past the lobby and the fluids. We have to look at the metal itself. There is a hidden world of counterfeit and third-tier parts that are currently flooding the U.S. market, often packaged in boxes that look remarkably like the original Japanese branding. Do you know how to tell a genuine NGK spark plug from a high-quality fake that could melt a hole in your piston? In the next part, we are going to go under the hood to look at the specific physical markers of quality parts and the component scam that is currently costing American drivers millions. We are also going to reveal the shadow maintenance items that are never listed in your owner's manual, but are essential for keeping a Japanese engine alive in the harsh climates of the United States. Do you know why your 2026 Toyota might need a service that isn't even in the book? The answer might save your engine. The reason your 2026 Toyota might need a service that isn't in the official maintenance guide comes down to a fundamental disconnect between marketing and engineering. In the United States, automotive manufacturers are in a constant battle to lower the advertised cost of ownership. One of the most effective ways to do this is to extend service intervals or label certain fluids as lifetime. However, specialized Japanese auto repair shops look at the physical reality of the metal and the chemistry, not the marketing brochure. This brings us to the first major shadow maintenance item of 2026, intake valve carbon cleaning. Imagine if you are James, a graphic designer in Chicago. In 2026, James drives a 2023 Mazda CX-5 with the 2.5-liter Skyactiv engine. This engine is a masterpiece of efficiency, but it uses direct injection technology. By 45,000 miles, James noticed that his Mazda was hesitating slightly when merging onto the Kennedy Expressway. His fuel economy, which used to be a steady 28 miles per gallon, had dropped to 24. He took it to a general repair shop, and they told him that since there was no check engine light, the car was fine. But a Japanese specialist knows better. In a direct injection engine, fuel is sprayed directly into the cylinder, meaning it never washes over the back of the intake valves. Over time, oily vapors from the positive crankcase ventilation system bake onto those hot intake valves, forming a hard carbonized crust. The specialist performed a digital borescope inspection, sliding a tiny camera into the intake tract to show James the physical data. The valves were covered in a thick black sludge that looked like burnt popcorn. This is a shadow maintenance item because the owner's manual doesn't mention it, yet it is a documented historical trend in all modern Japanese direct injection engines. The solution is a process called walnut blasting. This involves using a specialized machine to blast crushed walnut shells at high pressure against the valves while they are closed. The shells are abrasive enough to strip the carbon, but soft enough to ensure no damage occurs to the aluminum cylinder head. A specialized shop in the US in 2026 will perform this every 50,000 miles as a preventative measure. The potential outcome for James was a total restoration of his engine's breathability, bringing his fuel economy and throttle response back to factory specifications. This leads us directly into the component scam and the spark plug crisis currently hitting the US market. Imagine if you are David in Arizona. It is 2026, and David is performing a 100,000-mile service on his Honda Accord. He sees a set of NGK laser iridium spark plugs online for $40. The local Japanese specialty shop wants $90 for the same set. David buys the cheaper ones, thinking he is being savvy. On the outside, these plugs are nearly perfect clones. They have the NGK branding, the correct part number, and the blue lettering on the ceramic. However, the internal engineering is a fraud. Genuine Japanese NGK plugs use a solid copper core for superior heat dissipation and a laser-welded iridium tip that can withstand the intense heat of a modern lean burn engine. The counterfeit plugs David bought often use a cheaper steel core. Steel is a poor conductor of heat compared to copper. In the high heat environment of an Arizona summer, that fake spark plug cannot shed heat fast enough. The tip of the plug becomes a literal glow plug, staying incandescently hot between engine cycles. This causes pre-ignition, where the fuel-air mixture ignites before the piston reaches the top of its stroke. In a high-stakes scenario, this pre-ignition creates a shockwave that can melt a hole directly through the top of a piston in a matter of seconds. Specialized shops refuse to install customer-provided parts for this exact reason. They source their NGK and Denso components from verified distributors like Worldpac or SSF to ensure the integrity of the engine. Historical trends show that the savings of $50 on parts can lead to a potential outcome of a $6,000 engine replacement. We must also address the lifetime fluid myth, specifically regarding the transmissions in 2026 Toyota and Lexus hybrids. The manual might say the transmission fluid never needs to be changed under normal driving conditions. However, the definition of normal in the US is extremely narrow. If you live in a climate with extreme heat, if you drive in stop-and-go traffic, or if you live in a hilly region, you are officially in the severe service category. In these conditions, the transmission fluid undergoes thermal cycling that breaks down the additive package. A specialist shop will perform a drain and fill service every 60,000 miles. It is crucial to understand the step-by-step detail of a drain and fill versus a flush. A high-pressure flush can be risky for a Japanese transmission because it can force metallic particulates into the sensitive solenoid screens. A specialist performs a gravity drain, removes the pan to clean the magnets which collect microscopic steel shavings, and replaces the filter. They then refill the system with the exact volume of genuine Toyota World Standard fluid, often using a scan tool to monitor the transmission fluid temperature to ensure the level is set perfectly at the expansion point. This precision is the difference between a transmission that lasts 120,000 miles and one that lasts 300,000 miles. Furthermore, we have the issue of the AWD systems in vehicles like the Subaru Forester or the Toyota RAV4. These vehicles use differentials and transfer cases that hold a surprisingly small amount of gear oil, sometimes less than a quart. Because the volume is so small, the oil becomes contaminated with moisture and metallic where particles vary quickly. A specialized Japanese shop in 2026 will recommend changing these fluids every 30,000 to 40,000 miles. They use specific heavy-duty gear oils like Modal or Ineos that are engineered to handle the high shear forces of Japanese all-wheel drive gear sets. If you follow the manual's advice of only inspecting these fluids, you are essentially waiting for the oil to turn into a black, abrasive paste before you act. The shadow maintenance list also includes the hybrid battery cooling fan. In 2026, millions of Japanese hybrids are on US roads. These batteries generate immense heat during the regenerative braking process. They are cooled by a dedicated electric fan that pulls air from the cabin. Over time, this fan becomes clogged with dust, pet hair, and lint. If the fan is restricted, the battery runs 10 degrees hotter than intended. This doesn't cause an immediate failure, but it accelerates the chemical degradation of the battery cells. A specialist shop makes cleaning this fan a standard part of their 20,000-mile service. This is a 10-minute job that most general shops and even many dealerships ignore, yet it is one of the most effective ways to extend the life of a $5,000 hybrid battery pack. As we move forward in this deep dive, we have to talk about the most frustrating part of modern Japanese car ownership: the electrical ghost. In 2026, these cars are so sensitive to voltage that a single corroded ground wire can cause the entire dashboard to light up like a Christmas tree, throwing codes for systems that aren't even broken. Do you know why a simple 12-volt battery replacement in a 2026 Nissan or Mazda can actually disable your power steering if it isn't done with a memory saver? In the next part, we are going to look at the invisible electrical architecture of these vehicles and the specific ground point audit that every specialized shop performs to prevent phantom malfunctions. We will also dive into the truth about software updates and why your car might need a flash tune just to fix a rough idle. The ghosts are in the wires, and we are going to show you how to find them. The reason your 2026 Toyota might need a service that isn't in the official maintenance guide comes down to a fundamental disconnect between marketing and engineering. In the United States, automotive manufacturers are in a constant battle to lower the advertised cost of ownership. One of the most effective ways to do this is to extend service intervals or label certain fluids as lifetime. However, specialized Japanese auto repair shops look at the physical reality of the metal and the chemistry, not the marketing brochure. This brings us to the first major shadow maintenance item of 2026: intake valve carbon cleaning. Imagine if you are James, a graphic designer in Chicago. In 2026, James drives a 2023 Mazda CX-5 with the 2.5-liter Skyactiv engine. This engine is a masterpiece of efficiency, but it uses direct injection technology. By 45,000 miles, James noticed that his Mazda was hesitating slightly when merging onto the Kennedy Expressway. His fuel economy, which used to be a steady 28 miles per gallon, had dropped to 24. He took it to a general repair shop, and they told him that since there was no check engine light, the car was fine. But a Japanese specialist knows better. In a direct injection engine, fuel is sprayed directly into the cylinder, meaning it never washes over the back of the intake valves. Over time, oily vapors from the positive crankcase ventilation system bake onto those hot intake valves, forming a hard carbonized crust. The specialist performed a digital borescope inspection, sliding a tiny camera into the intake tract to show James the physical data. The valves were covered in a thick black sludge that looked like burnt popcorn. This is a shadow maintenance item because the owner's manual doesn't mention it, yet it is a documented historical trend in all modern Japanese direct injection engines. The solution is a process called walnut blasting. This involves using a specialized machine to blast crushed walnut shells at high pressure against the valves while they are closed. The shells are abrasive enough to strip the carbon, but soft enough to ensure no damage occurs to the aluminum cylinder head. A specialized shop in the US in 2026 will perform this every 50,000 miles as a preventative measure. The potential outcome for James was a total restoration of his engine's breathability, bringing his fuel economy and throttle response back to factory specifications. This leads us directly into the component scam and the spark plug crisis currently hitting the US market. Imagine if you are David in Arizona. It is 2026. And David is performing a 100,000-mile service on his Honda Accord. He sees a set of NGK laser iridium spark plugs online for $40. The local Japanese specialty shop wants $90 for the same set. David buys the cheaper ones, thinking he is being savvy. On the outside, these plugs are nearly perfect clones. They have the NGK branding, the correct part number, and the blue lettering on the ceramic. However, the internal engineering is a fraud. Genuine Japanese NGK plugs use a solid copper core for superior heat dissipation and a laser-welded iridium tip that can withstand the intense heat of a modern lean burn engine. The counterfeit plugs David bought often use a cheaper steel core. Steel is a poor conductor of heat compared to copper. In the high heat environment of an Arizona summer, that fake spark plug cannot shed heat fast enough. The tip of the plug becomes a literal glow plug, staying incandescently hot between engine cycles. This causes pre-ignition, where the fuel-air mixture ignites before the piston reaches the top of its stroke. In a high-stakes scenario, This preignition creates a shockwave that can melt a hole directly through the top of a piston in a matter of seconds. Specialized shops refuse to install customer-provided parts for this exact reason. They source their NGK and Denso components from verified distributors like Worldpac or SSF to ensure the integrity of the engine. Historical trends show that the savings of $50 on parts can lead to a potential outcome of a $6,000 engine replacement. We must also address the lifetime fluid myth, specifically regarding the transmissions in 2026 Toyota and Lexus hybrids. The manual might say the transmission fluid never needs to be changed under normal driving conditions. However, the definition of normal in the US is extremely narrow. If you live in a climate with extreme heat, if you drive in stop-and-go traffic, or if you live in a hilly region, you are officially in the severe service category. In these conditions, the transmission fluid undergoes thermal cycling that breaks down the additive package. A specialist shop will perform a drain and fill service every 60,000 miles. It is crucial to understand the step-by-step detail of a drain and fill versus a flush. A high-pressure flush can be risky for a Japanese transmission because it can force metallic particulates into the sensitive solenoid screens. A specialist performs a gravity drain, removes the pan to clean the magnets which collect microscopic steel shavings, and replaces the filter. They then refill the system with the exact volume of genuine Toyota World Standard fluid, often using a scan tool to monitor the transmission fluid temperature to ensure the level is set perfectly at the expansion point. This precision is the difference between a transmission that lasts 120,000 miles and one that lasts 300,000 miles. Furthermore, we have the issue of the AWD systems in vehicles like the Subaru Forester or the Toyota RAV4. These vehicles use differentials and transfer cases that hold a surprisingly small amount of gear oil, sometimes less than a quart. Because the volume is so small, the oil becomes contaminated with moisture and metallic where particles vary quickly. A specialized Japanese shop in 2026 will recommend changing these fluids every 30,000 to 40,000 miles. They use specific heavy-duty gear oils like Modal or Ineos that are engineered to handle the high shear forces of Japanese all-wheel drive gear sets. If you follow the manual's advice of only inspecting these fluids, you are essentially waiting for the oil to turn into a black, abrasive paste before you act. The shadow maintenance list also includes the hybrid battery cooling fan. In 2026, millions of Japanese hybrids are on US roads. These batteries generate immense heat during the regenerative braking process. They are cooled by a dedicated electric fan that pulls air from the cabin. Over time, this fan becomes clogged with dust, pet hair, and lint. If the fan is restricted, the battery runs 10 degrees hotter than intended. This doesn't cause an immediate failure, but it accelerates the chemical degradation of the battery cells. A specialist shop makes cleaning this fan a standard part of their 20,000-mile service. This is a 10-minute job that most general shops and even many dealerships ignore, yet it is one of the most effective ways to extend the life of a $5,000 hybrid battery pack. As we move forward in this deep dive, we have to talk about the most frustrating part of modern Japanese car ownership: the electrical ghost. In 2026, these cars are so sensitive to voltage that a single corroded ground wire can cause the entire dashboard to light up like a Christmas tree, throwing codes for systems that aren't even broken. Do you know why a simple 12-volt battery replacement in a 2026 Nissan or Mazda can actually disable your power steering if it isn't done with a memory saver? In the next part, we are going to look at the invisible electrical architecture of these vehicles and the specific ground point audit that every specialized shop performs to prevent phantom malfunctions. We will also dive into the truth about software updates and why your car might need a flash tune just to fix a rough idle. The ghosts are in the wires, and we are going to show you how to find them. To understand the electrical ghosts of 2026, you first have to understand that your Japanese vehicle is no longer a mechanical machine controlled by electronics. It is a high-speed local area network that happens to have wheels and an engine. In the United States, we are seeing a massive surge in what technicians call phantom failures. These are situations where a car displays 5 or 6 seemingly unrelated warning lights: power steering malfunction, blind spot monitor unavailable, secondary braking system error, and check engine. To the average owner, this looks like a total vehicle meltdown. To a generalist shop, it looks like a reason to start replacing expensive modules. But to a specialized Japanese auto repair expert, these are the classic symptoms of a voltage drop or a communication breakdown in the CAN bus system. Imagine if you are Elena, a freelance journalist living in Minneapolis in 2026. Elena drives a 2024 Subaru Outback. After a particularly harsh winter where the city used record amounts of liquid brine on the roads, her Subaru starts acting possessed. The infotainment screen flickers, the eyesight driver assist cameras turn off randomly, and the car sometimes refuses to start on the first push of the button. Elena takes it to a big box retail service center. They test the battery, tell her it is slightly low, and sell her a new one for $250. They install it, she drives away, and 3 days later the ghosts are back. This is because the generalist shop treated the battery as an isolated component rather than the heart of a sensitive ecosystem. A specialized Japanese shop performs what is known as a ground point audit. In a vehicle like Elena's Subaru, there are over 30 specific points where the electrical system connects to the metal chassis. Because Japanese engineers prioritize weight reduction, they often use thinner gauge wiring and specific aluminum to steel grounding points. In the Salt Belt of the United States, these points are prime targets for galvanic corrosion. When a specialist performs an audit, they aren't just looking for tight bolts. They use a high-impedance digital multimeter to perform a voltage drop test. The step-by-step detail of this test is where the masterclass begins. The technician connects one lead of the meter to the negative battery terminal, and the other to a specific grounding point on the engine block or the frame while the vehicle's electrical systems are under load. Headlights on, blower motor on high, rear defroster active. In a healthy Japanese system, the meter should read less than 0.1 volts. If Elena's specialist sees a reading of 0.5 volts, they have found the ghost. That half volt of resistance is enough to confuse the extremely sensitive sensors that report back to the car's main computer. The specialist doesn't just replace parts. They clean the grounding surfaces to bare metal, apply a specialized conductive anti-corrosion paste, and retorque the fasteners. This $150 diagnostic and cleaning service saves the owner from thousands of dollars in unnecessary module replacements. We also have to address the 2026 battery registration crisis. In the past, you could swap a car battery in a parking lot with a 10mm wrench and be on your way. In 2026, if you do this to a Mazda, Nissan, or Toyota, you are risking a system-wide shutdown. Modern Japanese vehicles use an intelligent battery sensor, or IBS, located on the negative terminal. This sensor tracks the age, internal resistance, and state of charge of the battery. As a battery gets older, the car's alternator changes its charging profile to compensate for the diminishing capacity. If you install a brand new battery but do not perform a battery registration through a factory diagnostic tool like TechStream or Consult3, the car still thinks the old, weak battery is installed. It will overcharge the new battery, potentially boiling the electrolyte and killing the new unit within a year. Even worse, on certain Mazda models, failing to use a memory saver during the swap can cause the steering angle sensor to lose its 0-point calibration, leading to a potential outcome where the electric power steering feels heavy or inconsistent because the computer no longer knows exactly where center is. This brings us to the controversial world of software-based repairs, often referred to as flash tunes or ECU reflashing. In 2026, many mechanical issues are actually just coding errors. Imagine if you are Marcus in Atlanta, driving a 2025 Honda CR-V hybrid. Marcus notices a strange hunting sensation where the engine RPM fluctuates slightly, while maintaining a steady 60 miles per hour on the highway. A generalist mechanic might suspect a fuel pump issue or a clogged injector. However, a Japanese specialist checks the TSBs, or technical service bulletins. They find that Honda has released a software update for the power control unit specifically to address this surging issue. The process of reflashing an ECU is a high-stakes operation. A specialized shop uses a stable power supply, not a standard battery charger, to maintain exactly 14.2 volts throughout the process. If the voltage drops while the computer is being rewritten, the ECU can be bricked, turning a $50,000 car into a very expensive paperweight. The specialist connects to the Honda servers, downloads the latest firmware, and pushes it to the vehicle. This is the 2026 version of a tune-up. It doesn't involve spark plugs or filters, it involves bits and bytes. Historical trends show that as Japanese manufacturers move toward more complex hybrid and turbocharged powertrains, these software updates become the primary method for fixing drivability issues and even improving long-term reliability. We must also discuss the CAN bus loop and the one bad apple scenario. In a modern Japanese car, all the computers, the engine, the transmission, the brakes, the airbags, and the infotainment talk to each other on a shared network. If one component fails in a specific way, it can pollute the entire network with digital noise. A case study from 2026 involved a Lexus owner whose car wouldn't shift out of park and whose windows wouldn't roll down. The culprit? A tiny bit of moisture had seeped into the blind spot monitor sensor located behind the rear bumper. This sensor, which seems minor, was shorting out the communication line that the entire car used. A generalist shop spent 10 hours trying to diagnose a transmission failure. A Japanese specialist used an oscilloscope to look at the communication waveforms on the network, saw the digital interference, and traced it back to the rear bumper in 45 minutes. This level of expertise is the invisible value of a specialized shop. They understand the topography of the wiring. They know that on a Toyota, the communication lines are often routed through the floor harness, making them vulnerable to spilled coffee or sunroof leaks. They know that on a Nissan, a failing brake lamp switch can actually prevent the cruise control from engaging and cause a limp mode in the transmission. They don't guess, they measure. As we conclude this segment on the electrical architecture, we have to prepare for the physical consequences of these systems failing. When the software is right and the voltage is stable, the car still has to meet the road. But the suspension systems of 2026 Japanese vehicles have evolved into complex, multi-link arrays with electronic dampening and active stabilizers. The way these systems are serviced in the US is often a tragedy of good enough parts. Do you know why a $300 quick strut from an online retailer can actually ruin the safety ratings of your Honda or Toyota? In the next part, we are going to dive into the geometry of Japanese suspension and the silent handling killer that most shops miss during a standard alignment. We are also going to reveal why your car's safety sensors might be lying to you after a simple pothole hit. The truth about your car's connection to the road is coming up next. To understand the invisible connection between your wheels and your car's brain, we have to look at the physics of a modern Japanese suspension system in 2026. For decades, US car owners viewed suspension as a purely mechanical concern. If the car wasn't bouncing like a trampoline and the tires weren't wearing unevenly, everything was assumed to be fine. But in 2026, the suspension on a Honda, Toyota, or Mazda is a precision-engineered geometry that serves as the primary data input for your safety systems. When this geometry is compromised by a single pothole or a cheap replacement part, the potential outcomes range from a simple annoying vibration to a complete failure of your automated emergency braking system. Imagine if you are Chloe, a nurse living in Pittsburgh. It is 2026, and Chloe drives a 2024 Toyota RAV4 Hybrid. Pittsburgh is famous for its brutal winters and even more brutal potholes. After hitting a particularly deep crater on her way to the hospital, Chloe notices that her steering wheel is slightly off-center, maybe by only 3 or 4 degrees. She takes it to a high-volume general repair chain. They put it on an alignment rack, adjust the tow settings until the machine shows green, and send her on her way for $89. On the surface, the problem is solved. The car drives straight. But 3 days later, while Chloe is driving in heavy rain, her pre-collision system suddenly slams on the brakes for no reason. This is the silent handling killer in action. The general shop performed a mechanical alignment, but neglected the electronic calibration. In 2026, Japanese vehicles utilize a thrust angle that must be perfectly synchronized with the steering angle sensor and the front-facing ADAS camera. When Chloe's car was aligned mechanically, the technician moved the wheels, but they didn't tell the car's computer that the 0 point of the steering rack had shifted. The camera, which is mounted behind the rearview mirror, was now looking in one direction while the wheels were pointed in a slightly different path. The computer perceived this discrepancy as the car entering a skid, causing the stability control to intervene aggressively. A specialized Japanese auto repair shop avoids this by performing a combined mechanical-digital alignment. This involves using a 3D laser rack that communicates directly with the vehicle's OBD2 port, resetting the steering angle sensor and the yaw rate sensor to ensure the eyes of the car are looking exactly where the tires are heading. This leads us to the great strut delusion. In the United States, the most common suspension repair offered by generalist shops is the quick strut. These are pre-assembled units that include the strut, the coil spring, and the mounting plate in one box. They are popular because they are fast to install, reducing labor costs. However, historical trends show that these universal assemblies are the enemy of Japanese engineering. A 2024 RAV4 Hybrid, like Chloe's, has a specific spring rate designed to handle the weight of the high-voltage battery pack in the rear and the electric motor in the front. Universal quick struts are often designed with a middle-of-the-road spring rate intended to fit 5 different trims, from the lightest gas-only model to the heaviest hybrid. When Chloe installs these generic units, her car's center of gravity shifts. The ride height might increase by half an inch, or the front end might dive more aggressively under braking. This change in pitch and roll is enough to throw off the calibration of the adaptive cruise control. A Japanese specialist shop refuses to use these generic assemblies. Instead, they perform a component-level rebuild. They retain the high-quality Japanese steel coil springs, which rarely fatigue, and replace only the internal strut cartridge with an OEM spec unit from KYB or Takako, the same companies that manufactured the original parts in Japan. This ensures the vehicle's handling dynamics remain exactly as they were when it left the factory in Aichi. We also have to dive into the chemistry of rubber, specifically regarding compliance bushings. If you look under a 2025 Honda Accord, you will see complex aluminum control arms. These arms are connected to the frame by rubber bushings. In Japanese philosophy, these aren't just pieces of rubber. They are vibration dampers tuned to specific frequencies. Many modern Hondas and Lexuses use fluid-filled hydro bushings. These are essentially tiny shock absorbers filled with glycol. A general repair shop will often replace a worn control arm with a $120 aftermarket unit from a local parts store. These aftermarket arms almost always use solid, cheap vulcanized rubber instead of the fluid-filled design. The result is a phenomenon known as invis noise, vibration, and harshness. The car that used to be a silent, smooth cruiser now feels like a vibrating tuning fork every time it hits an expansion joint on the highway. Even worse, the solid rubber doesn't allow for the specific fore and aft movement the engineers intended during braking, which can increase your stopping distance by several feet. A specialized shop understands that the metallurgy and the durometer of the rubber are non-negotiable. They will either press out the old bushing and install a genuine Japanese replacement, or use a high-end aftermarket arm from a brand like Hard Race or Mevitec Supreme that specifically replicates the fluid-filled technology. Consider a case study involving Robert in Texas, who drives a 2025 Lexus ES350. Robert's car developed a subtle groan when turning into his driveway. A general shop diagnosed it as a failing steering rack and quoted him $2,800. Robert sought a second opinion at a Japanese specialty shop. The specialist didn't look at the rack. They looked at the strut bearings and the lower ball joints. Using a wireless chassis ear, a series of microphones clipped to the suspension, they identified that the noise was coming from a dry-rotted dust boot on a ball joint. In 2026, Japanese manufacturers use a very specific high molybdenum grease in their joints. When the boot tears, the grease escapes and the joint begins to bind. The specialist replaced the $50 joint instead of the $3,000 rack. This is the difference between a technician who understands how Japanese components fail versus one who just guesses based on the loudest symptom. The final layer of this suspension deep dive is the 2026 tire crisis. Modern Japanese cars, particularly those with all-wheel drive like the Subaru Symmetrical AWD or the Toyota Direct 4 system, are extremely sensitive to tire circumference. If Robert replaces just 2 tires on his Lexus instead of all 4, and the tread depth difference is more than 2/32 NDS of an inch, the physical difference in rotation speed can cause the center differential to overheat. A specialized shop uses a digital tread depth gauge and an AWD roll test to ensure the drivetrain isn't being stressed. They understand that a tire is not just a piece of black rubber. It is the final gear in the car's transmission. As we move forward, we have to address the most misunderstood part of the entire vehicle: the braking system. In 2026, we have moved past simple hydraulics and into the era of electronic brake boosters and regenerative blending. Why can a simple brake pad change at a corner shop actually disable your hybrid's ability to charge itself? In the next part, we are going to look at the brake-by-wire revolution and the specific calibration steps that prevent your Japanese hybrid from losing its braking power on a long downhill grade. We are also going to reveal the copper-free brake pad mandate of 2026 and why the wrong friction material can make your silent Lexus sound like a garbage truck. The secrets of the stopping power are up next. The secrets of the stopping power in a 2026 Japanese vehicle begin with a fundamental shift in how the car perceives your foot. If you are driving a 2024 or newer Toyota Prius, a Lexus NX, or a Honda Accord hybrid, the physical connection between your brake pedal and the brake calipers is largely an illusion. We have entered the era of brake-by-wire. And in the United States, this technology is causing a massive wave of diagnostic errors in generalist repair shops. In these systems, the brake pedal is essentially a sophisticated input device, much like a high-end racing simulator controller. When you press the pedal, you are interacting with a stroke sensor and a feel simulator that mimics the resistance of a traditional hydraulic system. The car's computer then calculates how much stopping power you are requesting and decides, in milliseconds, how to deliver it using a combination of the electric motor's regenerative drag and the friction of the pads against the rotors. Imagine if you are Michael, a tech consultant in San Jose. It is 2026, and Michael's 2024 Lexus RX 500h is due for its first major brake service. Michael takes his Lexus to a local corner shop that has served his family for years. The technician there, who is excellent with older trucks and gas-only sedans, performs what the industry calls a pad slap. He removes the old pads, uses a C-clamp to force the pistons back into the calipers, slides in a set of $40 ceramic pads from a local parts hub, and pumps the pedal until it feels firm. On an older Camry, this would be a standard procedure. On Michael's 2026 Lexus, this is a recipe for an electronic disaster. By forcing the brake fluid backward through the lines without putting the car into a dedicated maintenance mode, the technician may have just pushed debris or high-pressure surges into the IEBB, or integrated electronic brake booster. This unit is a complex assembly of brushless motors and solenoid valves that costs over $3,000 to replace. Furthermore, because the car's computer was not informed that the mechanical thickness of the pads had changed, the regenerative blending logic is now out of sync. When Michael drives away, he notices a terrifying half-second delay when he hits the brakes, followed by a violent, jerky grab as the friction pads engage. This isn't a mechanical failure. It is a software calibration failure. A specialized Japanese auto repair shop handles Michael's Lexus with a completely different protocol. The step-by-step detail of a 2026 brake service starts with the scan tool. Before a wrench even touches a lug nut, the technician connects to the vehicle and enters the brake maintenance menu. This command electronically retracts the rear parking brake actuators and opens the internal valves of the brake-by-wire system to allow for safe piston compression. Once the mechanical work is done, the specialist performs a linear solenoid valve calibration. This is a digital process where the car's computer learns the exact bite point of the new pads. Without this calibration, the transition between regenerative braking and friction braking will never be seamless. Historical trends show that grabby brakes on Japanese hybrids are almost always the result of skipped calibration steps, not faulty parts. Then we have the 2026 copper-free brake pad mandate. This is a critical piece of information for any U.S. car owner. Under the Better Brakes Law, which reached its full implementation by 2025 and 2026, brake pads sold in the United States must contain less than 0.5% copper by weight. You can identify these pads by the N rating, often represented by 3 black leaves on the packaging. Copper was historically used as a lubricant and a heat sink in brake friction material, helping to reduce noise and dissipate heat. Removing it required a total overhaul of pad chemistry. Japanese manufacturers like Akebano and Advix, who supply the factory pads for Toyota, Honda, and Subaru, spent years developing ceramic and titanate-based alternatives that meet these environmental standards without sacrificing the silence Japanese cars are known for. However, the U.S. aftermarket is currently flooded with cheap, third-tier copper-free pads that meet the legal requirement but fail the performance test. These pads are often too hard, leading to a phenomenon known as rotor glazing. Imagine if Michael's Lexus now sounds like a screeching garbage truck every time he slows down at a stoplight. This is because the cheap pads are not compatible with the high-carbon steel rotors used by Japanese manufacturers. A specialized shop understands the chemistry of the friction. They will only use pads from the original Japanese Tier 1 suppliers. These specialists know that an Advix Ultra Premium pad is specifically designed to work with the regenerative heat cycles of a hybrid, whereas a generic store-brand pad will overheat and squeal because it cannot handle the specific thermal demands of a car that uses its brakes differently than a traditional internal combustion vehicle. We must also address the brake fluid crisis of 2026. Modern Japanese braking systems are designed around the viscosity of DOT4LV, or low-viscosity fluid. In a cold climate like Minnesota or Maine, standard DOT4 fluid is too thick. When the ABS or stability control system needs to pulse the brakes in a fraction of a second to prevent a skid, the thicker fluid moves too slowly through the microscopic orifices of the actuator. A specialized Japanese shop will never use a universal brake fluid. They understand that the response time of the safety systems is tied directly to the fluid's viscosity at sub-zero temperatures. They use specialized pressure bleeding equipment that ensures no air is trapped in the complex internal labyrinths of the electronic booster, a task that is nearly impossible to achieve with the old-fashioned pump-the-pedal method. Furthermore, we need to talk about the electronic parking brake or EPB. Gone are the days of a simple cable and a hand lever. In 2026, almost every Japanese vehicle uses a high-torque electric motor bolted directly to the rear calipers. These motors are incredibly powerful and sensitive. If a technician attempts to change the rear brakes without using a scan tool to put the EPB into service mode, the motor can attempt to engage while the caliper is removed, shooting the piston out of the housing and destroying the unit. This is a common $1,500 mistake made at generalist shops across the United States. A specialist knows that even something as simple as a rear brake job now requires a computer interface. The complexity of the 2026 braking system is a microcosm of why the generalist shop is becoming obsolete for Japanese vehicle owners. We are no longer dealing with simple friction. We are dealing with a synchronized dance of electrical signals, high-pressure hydraulics, and specialized chemistry. If any one of these elements is slightly out of alignment, the entire safety profile of the vehicle is compromised. Potential outcomes for the uninformed owner include reduced fuel economy, because the regenerative system isn't working at peak efficiency, increased stopping distances, and the constant annoyance of brake noise. As we move toward the final stages of this deep dive, we have to look upward. While the brakes and suspension keep you safe on the road, the climate control system is what keeps you comfortable inside. But in 2026, the air conditioning system in your Honda or Toyota is no longer just for your comfort. It is a critical cooling component for your car's computer brain and its high-voltage battery. The new refrigerants being used in the US are more expensive and more volatile than ever before. Do you know why a simple AC recharge at a discount shop could actually brick your hybrid's battery pack? In the next part, we are going to dive into the world of our 1234yf refrigerant, high-voltage AC compressors, and the specific dielectric oils that prevent your air conditioner from becoming a literal electric chair. The cold truth about Japanese climate control is coming up next. The cold truth about Japanese climate control in 2026 is that your air conditioning system is no longer a luxury feature designed to keep you from sweating during a July commute in Florida. In the engineering architecture of a modern Toyota, Honda, or Lexus, the AC system has been promoted to a mission-critical life support system for the vehicle's high-voltage battery and power electronics. If your AC system fails or is serviced incorrectly, the potential outcomes involve more than just a warm cabin. You are looking at a bricked battery pack and a vehicle that refuses to engage its drive motors. This is because, in 2026, Japanese engineers have moved toward integrated thermal management loops where the cabin's evaporator and the battery's cooling plates share the same refrigerant circuit. Imagine if you are Kevin, a real estate agent in Phoenix. It is 2026, and Kevin drives a 2024 Lexus RZ450e. As the desert temperatures climb toward 110 degrees, Kevin notices his AC isn't blowing as cold as it used to. Seeking a quick fix, he stops at a high-volume discount repair shop that advertises a $99 AC recharge. To the technician at this shop, an AC system is an AC system. He sees the service ports under the hood, identifies the R1234yf refrigerant label, and hooks up a standard recovery and recharge machine. This is the exact moment Kevin's $60,000 Lexus begins its descent toward a total system failure. The first point of failure in this high-stakes scenario is the oil chemistry. Traditional internal combustion vehicles use PAG oil, or polyalkylene glycol, to lubricate the AC compressor. PAG oil is highly effective, but it has one property that makes it deadly for a Japanese hybrid or EV. It is hygroscopic and electrically conductive. In Kevin's Lexus, the AC compressor is not driven by a belt. It is an electric scroll compressor powered by the car's 400-volt high-voltage system. Because the electric motor's windings are submerged in the refrigerant and oil mixture, the lubricant must be a dielectric, meaning it must act as an insulator. Japanese manufacturers specify a very particular type of POE oil, or polyol ester oil, which is non-conductive. If Kevin's discount shop uses a machine that was previously used to service a standard gas-powered Ford or Chevy, there is residual PAG oil in the hoses. Historical trends show that as little as 1% cross-contamination, just a few drops of PAG oil, is enough to compromise the dielectric properties of the system. Once that conductive oil enters Kevin's electric compressor, it begins to break down the insulation on the motor windings. This creates a high-voltage leak to the compressor's chassis. In a high-stakes scenario, the car's onboard isolation monitors will detect this leak and immediately shut down the high-voltage contactors to prevent a fire or a lethal shock to the occupants. The car becomes a 5,000-pound paperweight. The potential outcome? Kevin now needs a total system flush and a new $3,500 electric compressor, all because a shop tried to save him $50 on a recharge. A specialized Japanese auto repair shop avoids this through a strict step-by-step protocol. First, they utilize dedicated R1234YF machines that are SAE J2843 or J3030 compliant. These machines have a specific oil injection logic that prevents cross-contamination. More importantly, an elite specialist will often have a dedicated machine solely for hybrids and EVs to ensure that not a single molecule of PAG oil ever enters the loop. Before they even add refrigerant, they perform a vacuum decay test to ensure the system is perfectly sealed. In 2026, our 1234YF refrigerant is significantly more expensive than the old R134A, often costing 5 to 10 times more per pound. A specialist knows that guessing with such an expensive chemical is an economic disaster for the client. We also have to dive into the chiller technology. In a 2026 Toyota BZ4X or a Lexus hybrid, the AC system doesn't just blow air over an evaporator in the dashboard. It also pumps refrigerant through a heat exchanger called a chiller. This chiller is where the high-voltage battery's liquid coolant loop meets the AC's refrigerant loop. If Kevin's AC system is low on refrigerant because of a slow leak that the discount shop ignored, the chiller cannot pull heat away from the battery fast enough during a DC fast charging session. In Phoenix's heat, this causes the battery's internal temperature to spike. To protect itself, the car will drastically throttle the charging speed, turning a 30-minute charge into a 3-hour ordeal, and may eventually lock out the battery entirely to prevent thermal runaway. This is why a specialized Japanese shop treats an AC service as a thermal management audit. They don't just check the pressures, they use their factory diagnostic tools like TechStream to monitor the superheat and subcooling values at the chiller. They look at the expansion valve opening percentages to ensure the battery is getting its fair share of cooling capacity. They also inspect the AC condenser, which in 2026 Japanese vehicles is often a multi-layered unit that handles engine cooling, inverter cooling, and AC cooling all in one sandwich. A single stone chip or a buildup of road salt in these tiny fins can reduce cooling efficiency by 20%, which is enough to trigger a battery temperature warning light on a long highway trip. Furthermore, we must address the smell of failure. Many US owners complain of a musty gym locker smell coming from their Japanese cars' vents. A generalist shop will tell you to just spray some disinfectant into the intake. A specialist understands that in 2026, Japanese evaporators are designed with extremely dense fin counts to maximize efficiency in a small space. This density creates a perfect breeding ground for mold and bacteria if the drain tube is even slightly restricted. A specialist will perform an evaporator cleaning using a specialized foam that is chemically neutral to the coatings used by Denso, the primary AC manufacturer for Japanese brands. They will also replace the cabin air filter with a high-density HEPA unit that includes a polyphenol coating to neutralize allergens, a standard feature in many Japanese luxury models that generalist shops often replace with cheap, paper filters that offer no protection. The economics of 2026 make this clear. Your Japanese car's AC system is the heart of its thermal defense. When you choose a specialized shop, you are paying for the technical insurance that your high-voltage battery won't be compromised by a lack of specialized oil or a misunderstanding of the refrigerant's dual-purpose role. You are ensuring that the $10,000 battery pack in your vehicle remains in its optimal temperature window, which is the single most important factor in its long-term health. But even with a perfect AC system, a perfect suspension, and a perfectly tuned engine, there is one final hurdle every US car owner faces: the human element. In the final part of this masterclass, we are going to look at the final inspection and the future of ownership. How do you maintain the relationship with your specialist shop to ensure your vehicle reaches the 300,000-mile mark? We are going to reveal the digital health record for your car and why having a paperless service history is your most valuable asset when it comes time to sell. We are also going to give you the ultimate checklist to use when picking up your car from a shop to ensure the job was done to the standards we have discussed today. The final piece of the puzzle is coming up next, and it is the one that brings everything we have learned together. Do you know the one question you should ask a mechanic after they finish the job to see if they actually care about your car? You are about to find out. The question you need to ask your technician the moment they hand you the invoice is this: can you show me the replaced components and walk me through the specific wear patterns you observed? This is the ultimate litmus test for a specialized Japanese auto repair shop in 2026. In a high-stakes environment where a simple diagnostic error can cost thousands, A technician who truly cares about your vehicle's longevity will not only have your old parts ready in a bin, but will be eager to perform what we call a mechanical autopsy. This conversation is where the true value of your investment is revealed. If a technician can point to a timing chain guide and explain how the slight dishing of the plastic suggests that your oil change interval of 7,000 miles is pushing the limit for your specific driving habits in Denver, you aren't just paying for a repair, you are paying for an engineering consultant. Imagine if you are Thomas, a middle school teacher in Colorado. It is 2026, and Thomas drives a 2024 Honda Pilot with the IVTM4 all-wheel drive system. Thomas has reached the 60,000-mile mark, a critical junction for modern Japanese SUVs. He has followed this masterclass and taken his vehicle to a specialized Honda independent shop. When he asks to see the old rear differential fluid and the cabin air filter, the technician doesn't just show him a dirty liquid. He uses a white paper test to show the microscopic metallic glitter in the fluid, explaining that the high torque demand of the Colorado Rockies is accelerating the wear on the clutch packs. This level of transparency is a hallmark of the elite specialist. Historical trends show that owners who engage in this parts autopsy dialogue are 40% more likely to catch secondary failures before they result in a breakdown. The next pillar of this final deep dive is the digital health record. In the United States of 2026, the paper service manual in your glove box is a relic of the past. The most valuable asset you can possess as a vehicle owner is a centralized, high-resolution digital service history. A specialized Japanese shop will provide you with a cloud-based portal that stores every digital vehicle inspection, every thermal image of your electrical ground points, and every factory software flash version your car has received. This isn't just about record-keeping. It is about the economics of the secondary market. When Thomas eventually decides to sell his Pilot in 2030, a potential buyer will see a documented history of Eisen water pumps, Denso sensors, and Honda Type 2 coolant services. Potential outcomes for sellers with this level of specialized documentation include a resale premium of 15% to 25% over a vehicle with a generic or lost service history. In 2026, buyers are savvy. They know that a Japanese car is only as reliable as the hands that touched it. We must also establish the final pickup checklist. This is the step-by-step detail you must follow before you drive your vehicle off the shop's lot. Step 1. The Underhood Visual Audit. A specialized shop prides itself on the shokunin spirit of cleanliness. You should check for the presence of every plastic pushpin and clip. In Japanese vehicles, these clips are specifically designed for vibration management. If you see zip ties or missing fasteners, it is a sign that the technician lacked the specialized inventory required for your brand. Step 2. The Scan Tool Health Report. Ask the service writer for a post-repair scan report showing that all modules are in a green state and that the readiness monitors for the emissions and ADAS systems have been reset or are in the process of self-testing. Step 3. The Fluid Level Verification. It may seem basic, but in a 2026 Toyota Hybrid, the coolant level for the inverter must be at a very specific expansion point. Have the technician show you the level while the vehicle is on level ground. The transition from a generalist mindset to a specialist mindset requires an understanding of the 300,000-mile maintenance philosophy. In the US, we have been conditioned to believe that a car with 100,000 miles is old. In the specialized Japanese repair community, 100,000 miles is merely the end of the break-in period. To reach the 300,000-mile mark, you must adopt a preventative preservation strategy. This involves replacing components based on their known chemical or physical degradation cycles, not just when they fail. For instance, a specialist knows that the rubber gaskets on a Nissan VQ engine's oil gallery will inevitably harden and leak internal pressure after 10 years. Replacing them at year 9 is a calculated preservation move. Waiting for the oil pressure light to flicker is a high-stakes gamble with the engine's bearings. Case studies of high-mileage Japanese vehicles in 2026 show a clear pattern. The winners are those who utilize specialized independent shops for their midlife overhauls. This includes items like the preventative replacement of the hybrid cooling fan, the walnut blasting of the intake valves every 50,000 miles, and the use of specialized dielectric greases on every electrical connector that is disturbed during service. This is the level of detail that prevents the electrical ghosts we discussed in previous parts. It is the difference between a car that feels loose and tired at 150,000 miles and one that feels as tight as the day it left the factory in Japan. Furthermore, we must address the human relationship with your service writer. In 2026, The service writer at a specialized shop is your translator between Japanese engineering and American driving conditions. You should look for a shop where the turnover is low. If the same service writer has been there for 5 years, they have seen the life cycle of hundreds of Toyotas or Subarus. They know exactly how the local climate, whether it is the humidity of the south or the road salt of the north, affects your specific model. This institutional knowledge is something a dealership with a rotating door of junior employees can never replicate. As we conclude this masterclass on Japanese auto repair shops in the USA, remember that you are the CEO of your vehicle's health. The specialized shop is your technical staff. By demanding factory-level diagnostics, refusing universal fluids, and insisting on the parts autopsy conversation, you are ensuring that the engineering excellence you paid for is preserved. You are moving away from the fix-it-when-it's-broken culture of the 20th century and into the precision management culture of 2026. Your Toyota, Honda, or Mazda was built to last a lifetime, but it requires a specialized guardian to get it there. You now possess the vocabulary to vet a shop, the technical knowledge to challenge a generic diagnosis, and the roadmap for long-term vehicle preservation. But the world of automotive technology never stops evolving. As we look toward the next frontier, we are seeing a massive shift in how the next generation of solid-state batteries and hydrogen fuel cell powertrains from Japan will be serviced on American soil. The tools are changing, the fluids are changing, and the stakes are getting even higher. Do you want to know how the upcoming 2027 Japanese solid-state battery recalls will be handled, and why your current specialized shop is already preparing for a world without oil changes? Our next deep dive into the future of the Japanese powertrain is already in the works. The ghosts in the wires are becoming even more complex, and we are going to be there to help you find them.